This video is about formation of partial differential equation. Now you know how to classify partial differential equation. So this video is about forming partial differential equation. So how are you forming partial differential equation? There are two methods. The first method is eliminating arbitrary constants. And the second method is eliminating arbitrary function. So while eliminating arbitrary constant, you will be eliminating terms like a, b, c and constants like 1, 2, 3 also. And while you are treating to eliminate arbitrary functions, there you will be dealing with functions like x by y or some function of xz by y. These are certain examples. So let's begin by doing some problems. So generate a PDE for the equation z is equal to ax minus y. Here we are going to eliminate arbitrary constant. The arbitrary constant is a here. Since a is unknown, so let's differentiate del z by del x. Remember here z is a function of xy. So whatever partial differentiation we are going to do is doing for z. So del z by del x can also be treated as p, because p is equal to del by del x of the function z. Correct? So p is equal to a times 1 minus 0. So here we got p is equal to a. Now substituting this value in the differential in the equation that we have, we will get the partial differential equation as z is equal to px minus y. This is the generated partial differential equation. Now the method we used is eliminated the arbitrary constant. Here we have another example to generate PDE for the equation z is equal to function of xy by z. Here we will be eliminating the arbitrary function. The arbitrary function is a function of xy by z. So here p is equal to, notice that if we have a function like xy by z, then we will treat this as t, so that whenever we are differentiating with respect to x, we can do it as differentiate it with respect to t and differentiate t with respect to x. With this thing in mind, also remember that z is a function of x and y. So here this z should also be differentiated when you are differentiating with respect to x, because it should not be treated as a constant here, as it contains terms of x. So p is equal to the derivative of xy by z. This thing will be multiplied by, use the chain rule to find y by z minus xy by z square into p. You can also find q as this. So now divide p and q so that the arbitrary function, which is now looks like f dash xy by z, will be cancelled out, so that you can find p by q